Our team is going to present about problems that the Star Ferry in Hong Kong is having today and suggest some ways to improve them by incorporating scientific innovation that holds true to Hong Kong culture.
The main idea of our project is implementing electromagnets onto the ferry in order to have an effective and safe docking of the ferry to the pier. The ferry is docked to the pier by a rope in a ferry. This rope is hung and pulled to the harbor manually by a man, which has problems. Since waves are pretty strong near the deck, the ferry oscillates vertically severely. This is not only dangerous for passengers to get on and off from the ferry, but also brings discomfort and inconvenience to passengers inside the ferry who are waiting to get off. The man in charge of the roping might also get injured or make mistakes. To solve the problem, electromagnets can be utilized so that it can dampen the effects of the oscillation and the movement in the ferry by magnetic force between the ferry and the deck. Each of the mooring magnets generates a 1 Tesla magnetic field. The magnets are formed from long, thin, rod-shaped electromagnets placed side by side in a pattern that concentrates the magnetic field around the sides of the rods onto the side of the ferry. The proximity of the rods ensures that the field from each is attracted to its neighbors, rather than extending forward very far. This will reduce time in docking as well as adjusting to tidal waves to prevent rapid movement.
Our first sub-idea is thermochromic paints and photovoltaic paints. Firstly, thermochromic paints allows ferry to change its color depending on the sea temperature, making visual effects better. This will also take inspiration from bioluminescent algae found in Hong Kong. Furthermore, thermochromic sensors on ferry underside that detect temperature difference in the sea water and react to the temperature by changing color. Photovoltaic allows ferry to convert light from the sun into electricity for storage purposes, light functioning, charging stations in the ferry. The paint is composed of several materials. Solar paint hydrogen absorbs moisture from the air and uses solar energy to break water molecules into hydrogen and oxygen. Lastly but not least, hydrogen is generated to create clean energy for the inner processing.
Besides the main function of the ferry, generator can be attached at the bottom of the ferry. The electricity generated from the generator might not capable to operate the engine of the ferry, but the generated electricity will be useful for miscellaneous purposes of the ferry, such as electricity for lighting or audio systems. When the ferry moves, water resistance will make the propeller spin, and the faster it goes, the more resistance, hence greater amount of energy is produced. The kinetic form of energy is transformed into torque, which is also kinetic energy, and this torque is again transformed into electrical energy, which can be either stored in the form of chemical energy inside the battery or can be used in other forms of energy, such as sound energy, heat, or light energy.
Our last sub-idea is replacing the normal windows in the Star Ferry waiting area by smart windows, in order to make the waiting area more attractive and informative, since many of the Star Ferry users are foreigners and tourists. Smart windows allow people to see what they can see with the normal window, but at the same time, smart window is also a screen to display pictures or writings on the background. So using the smart windows, attractive artworks or sightseeing guides for tourists and foreigners can be displayed onto the walls of Star Ferry waiting area. You may wonder what is a smart window. This is Samsung's transparent smart window. Like a normal window, it is transparent, but it is also a display and a screen, meaning that you can display things on the window and also tap the window. So if we implement the smart windows at the Chim Sa Tree side of the Star Ferry Pier, we can display the buildings on Hong Kong Island and the information about each building at the same time using smart windows. Moreover, since we need electricity to operate the smart windows, we can use special tiles that has vibration and pressure sensors on them. These housed on the ground in the waiting area can detect and absorb shock and pressure from people's footsteps and convert them to electricity to power the smart windows in a process called electromagnetic induction. So this is the end of our CCST 9032 project video. Hope you guys enjoyed. Thank you.